Djamila Amimer, it is a pleasure to have you in this ms.ai chat.
Thanks for having me, Nancy.
Djamila, you are the CEO of Mind Senses Global, based out of London, and you work with artificial intelligence for a number of years. So please help us understand what's the difference between narrow AI and general AI, and what does it take to move from narrow AI to general AI? And maybe you can describe these two concepts a bit for our audience.
Yeah, that's a very important question, Nancy. So if we start with narrow AI, and sometimes we also call it weak AI. So this type of AI, this is mainly what we see currently. So most of the AI application are narrow, weak AI. And what that means is that the AI is specifically designed to solve a specific problem. So you take it out of its environment and take it to another environment, and suddenly it cannot perform anymore because it's been designed to solve a specific problem. So that is narrow AI. General AI, or what sometimes we call strong AI, is the type of general intelligence where it is supposed to surpass all human capability across the board. So it can perform in different environments, solve different problems. So those are the main differences between narrow AI and general AI. Now, in terms of how we can move from narrow to general, I think that's kind of like the big question that everyone is trying to solve, especially the big players. In my view, and this is also the view of Mind Senses Global, is that we will need 4 main blocks to move towards general intelligence. So the first block, which I call causal reasoning. So the current AI we have is mainly based on statistical correlation. So if we take the example of fever and malaria, the machine will find correlation between fever and malaria. But the current machine we have does not understand that malaria causes fever. So that's the causal aspect. We will need to build machines that can start understanding cause and effects. So that's my first block. The second block I call computational data. So I'm sure you must you know that especially with the advancement of deep learning, most of the type of problem that AI is solving needs a huge set of data to be solved. And I think for us to move to general AI, we will need to find an efficient way to compute data. We can no longer, go bigger and bigger and bigger and bigger. We will have to find an efficient way to make computation. So that could be quantum computing, or it could be other type of computation. So they're like the like of DARPA, that's the US Defense Agency, who is looking at, for example, insects and how insects, kind of like model and deal with data. Because obviously their brain power or body, kind of proportion compared to their body is small. My third block is the transfer of learning. So how can we make a machine take that learning and apply it in another area? It could be us in the same area. So if we take the example of a toddler, a 2-year toddler. So if you give an image of a cat to a toddler, you may give it 2 images, 3 images, maybe at the maximum 10 images, and then the toddler will be able to understand what is a cat and describe it, how it looks, the sound that a cat, kind of does, and so on. However, for machine learning in deep learning, we will have to show thousands and 100,000 of cats of picture to the machine to understand and be able to pick every single time the picture of a cat. So that's my third block. And then my last block is algorithms. So I think for us to move to general intelligence, we will need to go into a new wave of techniques, a new wave of algorithms. We can no longer kind of use kind of the known techniques to go into this new area. So I think kind of building on those 4 blocks, I think this will enable us to move from narrow to general AI.
Fantastic. Excellent explanation. Very clear and crisp. Thank you, Djamila.
You're welcome.